Okay, so we're going to start on lesson 2. So you should have completely finished your quiz and all of lesson 1 material by now. So we're going to go ahead and get started on lesson 2, and you should have done the bell work, which was to create your own number trick that ends in the number 9. Okay, so let's talk about what the benefit in lesson 1 was of using a bucket. So a bucket represented your original start number, but it also in the end, like, it could have contained some marbles and some numbers. So you may say it's just a placeholder or a spot that represented a number that we may not have known as well. But we can represent, we can use other items other than a bucket, and you actually will see that moving forward. We're going to change it to other shapes or letters or just whatever it may be. But I want to ask you here, I'll pull up my camera here. So I want to ask you, what happens if we were to end in something like this? So you got 1, 2 buckets, and let's say 3 marbles. That's what you have. What if we ended there? Could you still figure out how many the bucket represented? Or would you need something else? If this was the only thing you had, could you figure it out? We've done problems like this, but it always had an equaled some number, okay? And we could figure that out. But we would have to go somewhere to figure out what's in the bucket, right? We'd have to move these to the other side. We'd have to do some other math to figure out what's in the bucket. If I just look at that part, I have no idea what's in the bucket, okay? So let's kind of work through here. You should have created your own, and we went over some of these in class. Okay, so Maria was working through a different think of a number trick, and she started with the number 2. And after one step, she ended in 8. So she went from 2 to 8. So name 2 ways that she could have got there. So I'm going to do one, and then I'll leave one for you to do. So how can I go from 2 to 8? Okay, she started with the number 2, and then she went to 8. So the first thing I think of, which may not be the first thing you think of, is, well, we just multiplied by 4. Okay, if you take 2 and multiply it by 4, you get 8. Okay, it has nothing to do with buckets or marbles or anything like that. It's just numbers. So I want here, you're going from 2 to 8. I want you to write your own, okay? So in this problem, another puzzle started with the number 5, and after 2 steps had 11. Okay, so you started at 5, went somewhere again, and 11. Okay, so 2 steps, and I'm gonna be at 11. Okay, so let's see here. The first thing I think of is we take this number, and if we double it, so multiply by 2, I get 10, and then go from 10 to 11, I just add 1. Okay, now yours will be different, and it doesn't have to be multiply first. It could be add first and then divide, or something like that, or multiply by number and then subtract. It's just whatever your 2 steps are. Okay, so you got that one to fill out. All right, let's do these odd ones over here. Okay, so if 2 buckets and 5 marbles equals 25, what's 1 bucket? We should know this one. Okay, we take away the 5 marbles from both sides, You get 20 over here. So if 2 buckets is 20, then 1 bucket will give you 10. Now look what they did here in number 7. Okay, now we've changed the shape, but does changing the shape really change the problem? Instead of writing it like this with buckets and marbles, if I write it like this, could it still be buckets and marbles? Yes. Okay, we could have a bucket and a bucket and 1 marble equals another bucket and 3 marbles. Okay, it's the same problem, we're just representing it in a different way. Okay, and it says, what's a diamond or what's a bucket equal? Well, if you notice, we got buckets on both sides. If I have a bucket over here and a bucket over here, or a diamond over there, those cancel each other out. Okay, so I have a bucket and a marble equals 3 marbles. Well, I can cancel out a marble, and I have 1 bucket equals 2 marbles. So a diamond would actually equal 2. Okay, same thing here with the pentagon. So give that a try. We had this the other day, so I'm gonna let you give that one a try. Now let's turn the page here. We're gonna start looking at mobiles, okay? And this is just balancing an equation, okay? So on 9 through 12 or 16 here, we're just gonna look at just the mobiles, okay? And what it is, if you don't know what it is, this is a string that's hanging, and this is like a rod, and it's kind of balancing here. And they're just going to ask us some questions about it. And it can represent any type of equation. So it's really, we're just using gravity here to kind of help us balance shapes and balance equations, ultimately, is what we're looking at. So I'll do some of these, and I'm going to leave some of them for you to do. So this mobile always balances, and why? Okay, well, if we look at this side, we have 1, 2 buckets and 1, 2, 3 marbles. Okay, does this equal that? It does. I've got 1, 2 buckets and 1, 2, 3 marbles. So it will always balance because there are equal buckets and marbles on each side. Okay, equal buckets on each side. Now, this mobile will never balance no matter what number is represented in the bucket. Why? Okay, well, if you notice, we have equal buckets on each side, right? There's 2 buckets over here, 2 buckets over there. So if those represent all the same number, remember what I said on the other page is that we could just cancel them out. So if you cancel here and cancel here, what do you have? Well, you got 2 marbles on this side and 1 marble on this side. The buckets don't matter, okay? So we can say the buckets cancel, and the 2 marbles versus 1 marble doesn't equal. Okay, they don't equal. So I'll leave some of these to you here to kind of try out, challenge yourself. Let's jump here to 16. Okay, how many diamonds does 1 heart weigh? Well, this thing is balanced out. Okay, and we got a diamond here, just pair them up. Okay, so those cancel, those go away. So this 1 heart, in order for this to balance, this 1 heart has to equal both of those. So 2 diamonds equals a heart. Okay, there we go. So write and discuss what you think. Okay, so there's only one number that a bucket can represent that makes this equal 2 buckets and a dot. That makes this true. What is that number? Okay, what is the number that can make that true? Okay, well, we can think of it as a mobile. Okay, and we could draw this. This is one side and this is the other. Well, we've got buckets on both sides, so get rid of that bucket and get rid of that bucket. We've got a dot here and a dot here. Those cancel. Well, then I got 1, 2, 3, 4, 5 equals a bucket. So it must be 5 can be the only number that makes that possible. Okay, so I'm going to give you some time here. You can go ahead and, oh, nope. We're going to, I'll do a couple here. I'll do a couple more here on the stuff that makes you think. All right, so let's see here. Let's do 20. If 2 buckets equals a bucket and 3 marbles, then what number or numbers can the bucket represent? Okay, so we've got the buckets cancel on each side. And it looks like we have a bucket equals 3 marbles. So 3 is the only thing that it can represent. Okay, the only thing that it can represent. Okay, so here it looks like we've got 2 buckets equals 1 bucket. Then what numbers can the bucket represent? Well, again, your buckets cancel, but there's still something over here, okay? And that would be 0. It went away, but we have 0 still holding that side. So 0 is what the bucket is going to represent. Okay. Now, there's a couple things we could say, like, well, what if I had a bucket equals a bucket? If you have a bucket equals a bucket, that means you can choose any number. Any number will work. Or you'd really cancel it out and 0 equals 0. It wouldn't matter what numbers you had originally. Okay. And then, well, what happens if I get down to 1 marble equals 2 marbles? Okay. Well, a marble cancels a marble, so you're really getting 0 equals a marble. This is my 0 because that's my marble. Well, 0 can't equal a marble, and therefore you wouldn't have a solution. Okay, a marble equals 1. It does not equal 0. So if you have a marble equals a side with 0 on it, that's a problem. Okay, and that's kind of what you're asking here on number 22 is create one that has no solution. You're going to use that fact right there. For each problem, determine if the mobile balances, always, sometimes, or never. If it balances sometimes, say when. If it never does, cross out some pieces to make things balance. Excuse me. Okay, right here on 24, it says that this will sometimes balance when the bucket equals what? Okay, well, I've got 2 buckets, but I got 4 dots over here. So I got to group these 2 dots into these 2 buckets, or these 4 dots into these 2 buckets. So I got to take 2 to that bucket and 2 to that bucket, and then it'll equal. So it will only equal if there's 2 marbles in each bucket. Okay, let's go to this one right here. Okay, I've got a bucket for a bucket, so those will always balance. I got a marble for a marble, so those will always balance. And I got a marble for another marble. Will those always balance? Yes. So this will always balance. Okay, so that's kind of what you're looking at as you're going through here. Let's do number 28 here. So you got a bucket and a bucket. Those will always balance. Another bucket and a bucket that will balance. But then a marble and a marble will balance. But then this one's still left with one marble left over. So this will never balance because of this single marble right there. There's nothing on this side that can balance it out. Okay, you can't just put a single marble in this bucket. If you put a single marble in this bucket, it adds a marble to all four buckets that are already balanced. Okay? All right, let's look at some of this tough stuff. Do these balance? Always, sometimes, never. If it balances, sometimes, say when. Oh, so we've got mobiles within mobiles. Okay, so we have to make sure, gives us a hint here, make sure both beams in the mobile balance. The beams and strings weigh nothing. Okay, so we're just looking at the cups and the marbles. Okay, so will this bar balance? Okay, so we got a bucket and a marble, so that's balanced, so that's good. Okay, and then this string has a marble, plus it has these two buckets and these two marbles. So on this string, we really have 6 buckets. Sorry, we have 2 buckets and we have 3 marbles. Do I have 2 buckets and 3 marbles over here? So 1, 2 buckets and 1, 2, 3 marbles. So 2 buckets, 3 marbles. Will it balance? Yes, because this is the same as this. So this is an always. Okay, I'll leave you this. It may be sometimes. Okay, if it is sometimes, say when it will balance. What must the bucket equal for it to balance? Okay, let's go to this one right here, and we'll end on this one. I'll let you guys kind of work through the others on your own. And then in the second video for this lesson, I will go through them. Okay, so we've got 2 stars plus 5 equals a star plus a star. Okay, it says for each problem, determine if the equation is true always, sometimes, never. If it's true sometimes, say when. If it's true never, say why. Okay, so we got a star on this side and a star on that side. Those can go away. Those will always balance each other out. We got a star there and a star there. Those will always balance each other out. So I have 5 on this side, but I don't have anything on this side. I have 0 on that right side. Will 5 equal 0? No. So this will never balance. Okay? And you could say 5 does not equal 0. Okay? It's just like this. Pretend we had 5 marbles right there. That's why it would never balance. Okay? So go ahead and finish through that. Get all of those tried, and then we will come back with the second video.